Hey folks, today I want to do an introduction video to Entity Framework. I want to talk about what it is, how it works, how you use it. I'll give you a few tips and also a few things to be careful about when you are using it. Entity Framework is an ORM, which stands for Object Relational Mapper. And that basically just means that it's going to take objects in your code and map it to things in your database. And then you can use those objects in your code to query them, and it will turn those queries into queries that will go to your database so you can actually get that data out. Entity Framework does that mapping with what's called a database context. And in this video, we're going to create the database context. We're going to create the entities that map to the tables in our database. And then I'm going to show you how to do some basic CRUD, which is create, read, update, and delete on those entities, and then how that creates the queries that go to the database. In this demo, I have a very simple web API, and I'm using Postgres as my database. For this demo, I do already have my database created and some data inside of it. Since this is basically a brand new API, the first thing we'll need to do is install a couple of NuGet packages. I'll open up my NuGet package manager and I'm going to search for Microsoft Entity Framework. We want to choose Microsoft Entity Framework Core and go ahead and install that. The next thing I need to install is the NuGet package for Postgres for Entity Framework. Entity Framework does work with quite a few databases. It will work with MySQL, SQLite, SQL Server, Postgres, and some NoSQL databases such as Mongo. And the one we want to install is npgsql.entitymframeworkcore.postgresql. The next thing we need now is an object that we're going to map our database table to. So I have a database that's already created. This one has a few different tables in it. And the tables I want to work with in this demo are user, post, and comment. So think of this as a threads clone where you have a user who can create a post and then other people can comment on it. And this here is the definition of this user table. And I got that by just right-clicking and then saying script as create. And what we need to do is we need to create a C# class for this user that is going to represent this table. And honestly, one of the easiest ways to do this is to use AI. So I'm going to go to ChatGPT and I'm going to have it create the class for me. And I'll show you why I use AI to do this here in a second. So I will go ahead and copy this. This is the main part that we actually need. And then in ChatGPT, I'm going to tell it what I need it to do for me. Here's the prompt that I gave ChatGPT. Create me a C# class complete with data annotations for required fields, max lengths, etc. for this Postgres table. And then I just pasted in that create table definition that was printed out earlier. Here's the output that it gave me. I'm going to copy this and put it in our project, and then I'll explain what all these different things are. I've created a user class inside of a folder called entities. I like to put my entities in this folder. You can put it wherever you would like. And then I'm just going to paste in what ChatGPT gave me, leaving the namespace in there. The reason I had ChatGPT do this for me is because it created it with all of these data annotations like I asked it to. And these data annotations are great because they do a couple different things. If you're going to use migrations, which I won't talk about in this video, but I've done a video on it in the past, I'll put a link to it here. Migrations will use these data annotations to create those columns in the correct way. So for example, the ID right here is our primary key. And we're telling it that it's going to be the database generated identity for that. Down here for name, we're telling it that it's going to be required, so it will be non-nullable. String length, this actually needs to be max length, I think. So I'm going to go ahead and change that to max length. This will create a character varying field of a maximum length of 100. And then similar thing for email. And we also added the email address annotation on here. The other cool thing about annotations is that we can use this for validation when our objects come into our API. And so this annotation will automatically validate that this email is in the correct format for us. And lastly, same thing for the date time for date of birth. There are a lot of annotations you can add into your entity and its properties to make sure that the database gets created correctly or that it gets validated correctly. I'm not going to go over all of them. There's a max length, there's a min length. You can specify ranges for integers. You can also specify default values. One annotation that I didn't add in here that I'll point out because some people will have to use this is the column annotation. What is really nice about this column annotation is you can use a different name for your column than what is in the database. Let's just say, for example, that our date of birth column in the database uses snake case. For in my column annotation, I can add what that name is going to map to in the database. So it could be date of birth. And that's a pretty common thing, especially for Postgres, because Postgres usually doesn't use capital letters in its column names. So that's a good trick to know. I did use capital letters in mine though, so I'm just going to go ahead and take that out. Now that we have an entity that maps to that table in our database, we need to tell Entity Framework how to use it. And that's what the database context comes in. So I'm going to go ahead and create a database context. I'm going to put it in a directory called data. It doesn't have to be in this directory. It can be anywhere in the project that you want it. But I'm going to say add a new class. I'm just going to call it default DB context. You generally want to keep the name of DB context somewhere in the class name just so that you know what it is. That's just kind of a standard practice that most people follow. And we're going to add a couple things in here. First of all, it's going to inherit from DB context. So I'm going to go ahead and select that, and JetBrains Writer is going to automatically import my using statement for me. But if your IDE doesn't, make sure that you add using Microsoft Entity Framework Core. Quick little tip for constructors, I think Visual Studio does this too. If you type ctor and then tab, it'll automatically fill it in for you. We need to add a couple things into this constructor because we're inheriting from that class, and so our base class needs certain things to be passed into it. So first I'm going to add base, and then I'm going to say options, because we're going to pass in some options to that DB context. And since we need those options, we need them to be injected into our constructor. And that is DB context options. I'll give it the name of options, which matches this. And then the way that this context maps those entities to tables is by what's called a DB set. And so all we have to do is create a new property of the type DB set that tells it to use that entity. So I'll say public DB set, and the type is user because that's the entity that we have. And then I'm going to call it users, and then I'm going to add my get and set on it. And it's just complaining because it's not imported. Command period is a shortcut I just used there to add that. Now let's go into our program file and make sure that this DB context is being used in our app. In our program file, I'm just going to go ahead and paste this in and then describe what all of this does. And after I paste this in, I'm just going to go ahead and import all of my using statements that I need. And what this does is it adds a DB context into our service collection, which basically just makes it so that it works with dependency injection. And we're going to give it the type of the database context that we use. In my case, it was default DB context. And then we're going to pass it those options. And in our case, we're going to tell it to use Postgres. And then I'm passing it the connection string. In this connection string, I have this set up in my app settings. So I'm using the configuration object to go get that connection string from app settings. So if I open up my app settings, I'm going to go ahead and just paste in mine here. So this is the connection strings section. The name is demo context, and then this is the connection string to my database. I am running this database on a Docker container. If you want to see how to do that, go watch this video. But this connection string will be to wherever your database is or where it is going to be. Now our application is all set up to use the database context with our user entity. And so let's go actually use it. I'm going to create a controller for our API called users controller, and I'm going to use this database context to retrieve the users. In my controllers folder, I'm going to add a new controller called users controller. I'm going to inherit from controller base. I'll just quickly add in the annotations that I need for this controller. And now what we need to do is we need to inject our DB context into our controller. And again, I'll use ctor, and then we're going to inject that DB context. So default DB context. I'm just going to call it context. One cool tip for JetBrains Writer, if you do control period on this and you can say introduce read-only field, that will automatically create a private read-only field in your class, and then it will assign it inside of your constructor. I use that all the time and I absolutely love it. And now let's create an endpoint that we can call to get our list of users. Here is a really simple endpoint. It's an HTTP GET. I'm calling it all users, and I'm just going to return an action result from this one. And let's just start with the easiest query that we can run for this, which is just give me all the users. And to do that, I'll just say var users equals context.users, and I'll say toList async, and obviously I need to await this. And then we'll just say return OK with our list of users. Before I run this, I want to explain what this is doing. So context is our database context that we created earlier. Users is our users DB set. So that is referencing this user's property in the database context right here. And then we're just saying toList async. And what this is going to do is it's going to create a SQL statement, send that to the database, and it's going to retrieve all of the users out of the database for us. And then lastly, we're just going to return a 200 OK with all the users inside of it. And let's run this and make sure that this is working. In Swagger, I now have this user's endpoint. I'll say try it out, execute, and I return to 200 with all of my users inside of it. And if you're pretty new to Entity Framework, you're probably thinking, wow, that's a lot of things that just happened, and it seems like there's a lot of magic going on, which is very true. There is a lot of magic going on under the hood with Entity Framework. First of all, how did it get that from the database? Let's go back into our code and I'll talk about that. And the way that this works is when you call toList on this user's DB set, the database context is going to create a SQL query that Postgres is going to understand to get that user information out of the database. And how exactly it creates that SQL query will depend on which database engine you're using. And since I'm using Postgres, that's going to be a little bit different than if it was SQL or MySQL or Oracle. But this toList command is opening a database connection to the database. It is going to create the SQL query, pass it to the database, get the information back from the database, map the data that came back from the database query into this user's object, and then it's going to clean up and dispose and close of that connection for us. And I want to show you how to look at that SQL query being sent to the database so that you know that the query is being sent in the correct way. And there are a couple different ways that you can do this. In the project that I'm using, it actually is doing it automatically for me. And if you go into your app settings file, this logging section right here, these log levels, will determine what is being printed out to your console when you run your application. And so these different log levels represent different tiers of logs in your application, and it's going to restrict what does or does not get printed out. In this case, the default is anything that's an information level or higher gets printed out. And for Microsoft.ASP.NET Core specifically, anything that's a warning or higher will get printed out. So if I run this again and I execute that query from Swagger, if I go back into Writer, and in my console down here, you can see that it's printing out an information log of that actual query. So it's saying that the database command is being executed, and this is the actual SQL query being sent to the database. And I would recommend, if you are new to Entity Framework, or even if you're an experienced developer, that you go check these queries every now and then, because you want to make sure that what you're writing in your code is being translated into database queries correctly. What's nice about this is I can copy this, and I can go into my database, and I can paste that in there, and I can run it, and I can see exactly what's being run on my database. So those queries that are printed in that console will map directly to your database. Let's look at more things we can do when querying this database. So let's create another endpoint where we want to get a single user. So I'm going to go ahead and copy this one that I have here. I'm going to call it get user. This is going to be a slightly different route. I want to pass in the ID of the user to get that user back. So I'll say ID, that will be an integer. And then in here, I'll say integer of ID. And now, instead of returning a list of users, I want to only get a single user. And there's a couple different ways you can do this. The way I prefer to do it is to use first or default. So I'll say first or default async, and then this will take a lambda expression. So in our case, I'm going to say the user ID is equal to the ID that we passed in. That's not a list of users anymore, it's a single user, so I'll change the name. The first or default method is going to return the first object in the database that it finds that meets your criteria, and it's going to return that first object. If it doesn't find any records, it's going to return the default value of whatever that object is. In our case, a user is a class, and so the default would be a null. And now let's go ahead and run this. Now on my user's controller, I have a new endpoint that can accept an ID. So I believe I have a user ID of 1 in here. So that returns a single user with that ID. Now, what other ways could we have queried this? Well, first or default, like I said, will return the first object. You could also use find async. And find async may actually be a better option for this case in particular because it's going to search by the primary key value. When we did first or default, you can give it whatever predicate value you want to go search for it. In our case, we used the ID, which is the primary key. So it's going to give us the same result. One small difference though about find async is that if you look at the description here, it says, if an entity with the given primary key value is being tracked by the context, then it is returned immediately without making a request to the database. I'll explain a little bit more about what that means when it's talking about something being tracked by the context, but just know that this could give you slightly different results if you are processing a lot of data in your application at one time. Find and first or default are probably the two main ways you want to search for a single object in your database. Now let's talk about lists of objects. I'm going to go back up to the original endpoint that we wrote that is going to get the list of users. And like I said, this is going to return all users in this list, which in our case is okay, but if this database table has 1 million records in it, you don't want to do this. So let's add in some filtering and some paging into this so that we don't get back everything all at once. I'm going to add in a couple different filters in here, and I'll show you why Entity Framework is so powerful. Now I've added 5 different query string parameters to our endpoint. And these 5 parameters are going to let me search for users by name, by a range of their birth date, and then also I'm going to be able to page the results. Let's just start by adding the filter for the name. So I don't want to return the list right away, and I don't want to await this right away. And I'm going to change this to just be called query. And we can basically stack up these filters on this DB set of these users by using what's called an iQueryable. by taking advantage of the iQueryable interface of this DB set. So if I go look at users, and if I go look at DB set, I'm going to go look at the implementation of this. You can see that this is inheriting from the iQueryable interface. And what that means is if we go back into our controller, I can now add a where clause to this. So I can say where the username equals the name that we passed in. And then I can say toList. But in our case, we have multiple different things we can filter on, and they may or may not have values for them. And what we do in that case is we say, I want to use the user DB set, but I want to use it as a queryable. And now we can basically add on those where clauses as we need them. So let's check this name. If the name is not null or empty, then I want to go look for it. And so we say query equals query.where the username equals name. And now we're able to conditionally add where clauses onto our DB set so that when it goes to the database, it's going to filter in the way that we want it to. And now we do the same thing for the date times for the birth date. So I'll say if the birth date has a value, then I want the query to be, I want to say where the birth date is greater than or equal to birth start. And so by passing in a start date and an end date, I can actually search for anything after the start date, or anything before the end date, or anything between start and end. So it's just a really cool way of searching for dates in .NET. I've used this quite a bit and I really like it. And then same thing for the end date, so I'll say birth end, and this is going to change to a less than or equal to birth end. Now we've filtered our object correctly, so now let's add the paging. I'll say var results equals, and now we're going to use that query that we have been using and adding the where clause onto. And the way that you page things in Entity Framework is using the skip and take. In our case, we want to skip however many pages we're on. So in our case, if we're on page 1, we don't want to skip anything. So we'll say page -1, and then we're going to skip however large our page size is. Then the next thing we want to do is want to take the number of items that are on our page size. So .take, and then this is just page size. And then lastly, we can say toList async. And then we need to await that so that we get the actual results, and then we want to return the results. And I'm not going to do it in this example, but you will probably want to add some validation to make sure that the birth date is, an acceptable date range, or that the page size isn't too large, things like that. And let's go give this a quick test. In our users endpoint, we now have these different options. I know that I have a user in there with the name of Jeff, so I'm just going to start with that and see what I get back. And I do get back an array with a single entity in it, which is the one user with the name of Jeff. And now let's try using the birth date. Let's return any user that was born after 1990. Now I'm getting back 3 users that were born after 1990. And let's just really quick check that we're getting the paging correctly. So the users are Alice, Bob, and Jeff. So let's just change our page size to 1, and I should only get back Alice. If I change the page to 2, I should get back Bob, which I do. And if I change the page to 3, I should get back Jeff, which is right. And if I just, for fun, if I change the page to 1 and size to 2, I'll get back Alice and Bob. So that's working correctly as well. Next, I want to talk about how we modify records in the database. But before I do that, I just want to take a step back and make sure that it's very clear on when the database is being queried. Because I've made this mistake myself. I've seen coworkers do this. I've seen people online do this where they're querying the database and they're not getting the results that they think they are, and it's because they aren't writing their .NET code correctly. In this example that we did here, this query is not being sent to the database until we call toList async down here, which means that all of these things that we're doing right here is we're just telling the iQueryable, the DB set, how we want it to go query the database. And basically we're just adding on where statements onto that iQueryable. And like I said, the reason that happens is because it is an iQueryable. If it's an iQueryable, you can add where clauses, you can add order bys, you can do all those things without actually going to the database. As soon as you turn it into a list, or if you turn it into an object that you're going to use in memory, that is when it goes to the database. So if you call any of these methods or any variations of them is when it's going to go to the database. And this isn't an exhaustive list, but it's going to be first find toList. If you iterate over the results of something, so for example, if I didn't call toList right here, and then I did a for each of that results set, that would call the database. So before it gets into that for loop, it'll go get those records from the database, and then you'll iterate over all the results. Really quick, I just want to show what those SQL statements look like if you do it the wrong way. So here again, I've searched for birth date by January 1st, 1990. I got back these 3 results. If I go into JetBrains Writer, you can see here is a database query. It's going to select everything out of the user table where the date of birth is greater than the parameter that's passed in. It doesn't show it here. I'll show you how to change that here in a second. And then I'm going to limit and offset, which is our skip and take for paging. Now if I stop this, and if I make one little change, if I call toList, so what I've done is I've changed this to await the call to a toList async for the users. And it's complaining about these not being IEnumerables because the where clause is going to be on an IEnumerable. So I'm just going to really quickly change that. And then you can see also down here, it's complaining because I'm trying to turn this into a list again. And now let's go run this and see how the SQL statement is different. So I execute that and you can see I got the exact same results. And this is why this can be a little bit misleading because you're like, oh great, this was working. I got back the exact same thing I did the other time. But if we go back into our IDE and you look at the query, this is just doing a select star from our user table. All right, so I'm done with that rant. I'm off my soapbox, but I just want to make sure that you keep an eye on how these queries are being run so that you're not affecting the performance of your database in a very poor way. Let's move on now to how we modify records. So for example, updating, deleting, or adding records into our database. I'll create an endpoint that's going to accept a record to edit. I'm not going to write a full endpoint to actually do a put of a user record, but I will show you how you get the record and how you modify the different fields and then how Entity Framework tracks those changes and sends the update to the database. I've added a put endpoint to update our user. It's going to have a route of the ID of the user, and I'm going to read from the body a user record, and then I'm going to go update it. The normal way of updating records in Entity Framework is first you want to go retrieve that record from the database. And then you make changes to the properties of that record, and then you call save changes on the context, which will send a SQL query to update any record that has been changed. And so the first thing we're going to do is we're going to go retrieve our record from the database. And I'm going to use the find async to go get the existing record. And again, I'll just do a quick check to make sure that that's not a null record, to make sure that we are getting back something. If the record is null, we'll just return a 404 not found. And now we want to update all of the properties of our record with the properties that are coming in from the record in the put. So I'll say existing.name equals user.name. And so all I've done is I've said the existing name is equal to our incoming name, and then the same thing for date of birth and email. And we do that by saying await context.savechanges async. And then assuming that that works correctly, you can either return a 204 no content, or you can return the updated record. It really just kind of depends on how you do your APIs. I'm going to go ahead and return an OK of that updated existing user. So what I'm going to do is I'm going to run this and I'm going to show you the output of the SQL that gets sent to the database, and then I'll talk about how this actually works under the hood. I went ahead and ran my Git up here. I'm just going to copy one of these records so I can use it in my update. So I'll go into my put. I will paste in the record that I'm updating. I'll add the ID of 4. Let's just change the name to say updated. I will execute that. We got back a 200 with the updated name. Let's go look and see what actually got sent to the database. In our console, we see that here is the select statement for the record by the specific ID that we passed in, and then is the update statement. And what's interesting about this is we're updating the user, but we only updated the name. We didn't update any other properties. And this is some of the under the hood magic the Entity Framework does. So even though we passed in an object that had all the fields on it, it recognized that we only updated the name from what was already in the database, and so it only updated that one property of that record. I'll show how that works. This is getting into the weeds a little bit, but I do think it's important to understand how this works. I'm going to add a couple breakpoints into my code here. I'm going to go into Swagger and rerun that update. So I'll go ahead and change this to updated again, execute, and I'm hitting this first breakpoint. And you can see that we're getting back this user record. But if you go into the context, the database context is going to keep track of all of the changes that have happened on that record. And it does that using this change tracker right here. And there's a whole bunch of stuff in here, but the easiest way to look at this when you're debugging like this is to use this debug view and then the long view. So I'm going to go ahead and view this, and you can see that the user has an ID of 4 and it's currently marked as unchanged. And basically this means that the database context read that record from the database, and so far nothing on that record has changed, which is true because we haven't changed it yet. So let's go ahead and we'll go down a couple lines. And before we call save changes, let's go look at the database context and see what it says now. Now you can see that the status of the entity is unchanged. However, the name does have some more information in it. So the value of the name is updated again, and it says originally it was this. It's keeping track of that property and how we've changed it. The only reason that this says unchanged is because it doesn't track the entity records at the entity level for every single change that you make. It doesn't run its full exhaustive check of what's been changed at the entity level until it needs to, which is what was going to happen right here before we call save changes. I'll show you another way of checking that here in just a second, but this is why when you call save changes, it's only updating the name record because that's the only record that we actually changed the value of. So I'll go ahead, I'm going to let that go ahead and run through, and I'm going to stop this, and then I'm going to add one more line in here, which is context change tracker and then detect changes. This detect changes method, you will almost never ever have to run this manually like this. But this detect changes method is basically what any framework does under the hood to go run its full exhaustive search of what has changed. Like I said, you almost never have to do this manually. It's maybe if you're just doing debugging or showing how this works like I am here. But I'm going to run this again and I'll stop at this debug step here and I'll show you how it's a little bit different. Okay, I'm going to say updated third time and execute. And now if I go into the change tracker, and if I go to debug view and long view, now you can see the status of this record is modified. And you can see it's also added modifier to this property. So under the hood, any framework is keeping track of your changes. And the only reason I'm really digging into this again is because of performance. Just like with iQueryables and when you are actually calling the database, you want to make sure that you kind of understand how this works. And the reason is because if you are pulling a list of, let's say 10,000 records and you're working through all of them and making a bunch of changes, any framework has to keep track of that. And it's pretty good, it's pretty fast, but just be aware that if you're working on a very large data set and the performance is getting a little bit slow, this might be why. And this is one of the pros and the cons of using Entity Framework. The pro being that it is letting you work with C# code as a C# developer. You don't have to worry about writing SQL queries to your database and it's just going to do it all for you. It allows for a better developer experience, but the con is that there's overhead involved in keeping track of all those changes for you. And again, that's just something to keep in mind as you're working with Entity Framework. All right, let's talk about adding and deleting records. I'm not going to do a full controller endpoint for each one of these. I'm just going to use the code that I already have here. And so let's pretend that this is a post endpoint and we're going to insert this record instead of updating it. I'm just going to go ahead and comment all that out. And the way that you add things into the database is with the add method on your context. So I'll say context add async, and then you pass it in your user. Obviously you want to await that, and that's it. Entity Framework is going to attach this record to the database context. Like I showed before, when editing, there's the modified status of a record and a property. There's a couple different statuses. Attached is one of them. Anything that is attached will get inserted into the database when it calls save changes. And if you want to delete a record from the database, you call remove on your database context. And when you remove a record, you do need to pass in the entire entity. And so you would actually want to go do the same thing like we did up above when we were updating a record, and you want to make sure that it exists first. And then if it does exist, then you can go ahead and remove it. And again, you do have to do that because of the change tracking and how it works with the database context. The context has to keep track of those changes that the record exists and that is then removed, and so it will pass that delete statement to your database. Oh, and I can't believe I almost forgot this, but if you add something or remove something from the context, you do have to call save changes. So await context save changes async, and that will actually, submit all that information to the database. I do also want to point out that you don't have to call save changes until you've completed all of your work. So for example, let's say you want to do a batch update and update 2, 3, or a whole bunch of records. You can retrieve the records, make all the changes you need to all at once, and then call save changes, and then the context will create the whole entire SQL statement all at once and send that whole thing to the database. I just want to point that out because I've seen people do, change one record and then update it and then change another one and then update it, and you don't have to do that. You can batch all of it. Now I want to talk about how you work with child objects of your entities. So far in this example, I've only been working with the user entity and only the properties on that user object. However, databases are relational, and so are our objects. In my example, a user can have multiple posts, and on those posts, you can have multiple comments. And Entity Framework has a very easy way of working with child objects or parent objects. In my database, I have users, which can have multiple posts, and then a post can have multiple comments. I've gone ahead and I've created a new entity called post, and this has the properties and data annotations that correspond to that record in our database, just like we did with users at the very beginning of the video. And now we need to tell Entity Framework that a user can have multiple posts and that a post can belong to a user. I'm going to start at the user, so I'm going to go into a user, and the way you do that is by telling it that a user can have a list of posts. So public list of post. I'm going to call it posts and then our get set on our property. And then we go into post and we do a similar thing with a public user with the name of user and then a get and set. When you reference a parent or a child in this fashion here, it's going to assume that if you have an object and you have a property on there with the same name and then an ID after it, those two things go together and that's the foreign key. We have a user ID and we have a user. Any framework is going to assume that those things go together. And that's how it's going to link those two things together. And now when we query our database using Entity Framework, we can include those records. So I'm going to go into my controller again, and I'm going to say, let's say that, for example, on this call to my user, I want to include all of the posts that user has. Again, you may not want to do all of them because there could be a whole bunch of them, but for the sake of this demo, I'm just going to return all of them. The way that works in Entity Framework is by using the include method. On users, I'm just going to say .include, and then you just give it the object you want to include. So I want to include posts. And now that I've added that include, you can see that it's upset with this find async, and that's because find async is going to return only that object and nothing else. So in this situation, you would have to use first or default. So I'll change that to first or default. And let's go run this in Swagger and let's see what happens. Try it out. I'll pass in, I believe the user ID was 4. I got an error running this, and it's because of how it is serializing the JSON. So I made a comment earlier about how there's different ways you can modify the settings for the JSON serializer so that certain things work in certain ways. And this is a situation where we have to go add this. The error is that a possible object cycle was detected. And the reason that that happens is because if we go back into our code, the user object that we're retrieving has a list of posts. Well, if we go into a post record, that post record has a reference back to the user. If you go back into user, it also has a list of posts. And so you can see how if it's trying to serialize that object, it's just going to keep going in a giant circle forever and forever and forever, and it's not going to work the way that you want it to. So we need to tell JSON to not serialize our objects in that way, to basically ignore those cyclic dependencies. And you do that by going into your program file, and we're going to add something onto this add controllers method. And so we need to tell it that when the controller is parsing the JSON to do it in a different way. And I'm just going to paste this in here because it's a little bit long. But after add controllers, we're going to say add JSON options, and then we're going to set one of those serializer options for the reference handler to ignore cycles. And again, this is just making it so that it doesn't keep going in circles when it goes from user to post to user to post. So now if we run this, we should get back the results that we want. I'll run that again for user 4. And now you can see that we get back the user record like we did before, but now we also have this posts array with all of their posts. And you can see that the user is null because that was part of that cyclic dependency, and so you don't want to include that multiple times. That's how you include the child records of your object. And if we had multiple child objects we want to include, you can add that multiple times. One thing to point out about this is that if you do an include like this, it's going to include all of the properties of your user record and all of the properties of your posts. Let's just say, for example, that your email property, you don't want to expose that in your API. Well, the other option is instead of doing the include and just returning the user's object, we can select exactly what we want to return. So I'm going to remove the include and I'm going to add a select. So .select. In this case, I'm just going to use a anonymous object. More than likely, you would want to have this set up as an actual, view model or DTO object that has the properties in it that you want. But just for this demo, I'm just going to say a new, and I'm just going to give it an anonymous type. And I want to include the ID. So that's going to be the user ID. I want to include the name, so I'll give it a name property. And then I do want to include all the posts, so I'll create a posts object, and I will just say that that is mapped to all of the posts. And now if I run this, I should only get back the user ID, the name, and then all of their posts. So again, I'll use record number 4, and I will run that. And you can see now I'm getting back only the ID and the name, and then I'm getting back all of their posts. And back in our code, I didn't show this last time, but when you do the include, it's going to include all of those properties in the select statement. And now you can see that when I'm selecting that record, I'm only selecting the ID and the name from the user, and then all of the post properties. And you can also see how Entity Framework is actually creating this query. So it's creating the user as a subquery that's going to return, and then it's going to left join the posts onto that record. And the one advantage of why you would want to do a select like this instead of just the includes is because you can specify exactly which columns you're retrieving from the database. For example, if we have a table that has 100 columns in it, and you only need 3 of them, there's no point in querying all of those columns, returning it to Entity Framework, having it do all the serialization and the mapping of those columns, only to use a few of them. It's just extra work for your application and for the database. So I would recommend using something like this as much as you can. And I think the last thing I'll show is something I forgot to show a little bit earlier. You can also order your queries, and you do that using the order by command. So if you say order by, and then you can give it a lambda, so you can order it by any property that you want. If you're doing paging like we were up here in our Git earlier, you should add an order by on there just so that you're always getting back the same results in the same order and you're not shuffling things around from page to page. There's also order by descending, so that will order them by descending by whatever you give it. And I think that's pretty much the basics of Entity Framework. I think if you take this knowledge and apply it, that's going to cover a pretty good chunk of the normal work you would do with Entity Framework. And obviously there's a lot more things we can do with the different commands because, you know, most of the things that you can do in SQL, there's a way of doing it in Entity Framework as well. If you're interested in an even more of a deeper dive into Entity Framework, let me know in the comments down below. I'd be happy to do that if people are interested. And if you have any comments or questions about something I did here, please put it in the comments down below and I'll get back to you as soon as I can. And thanks for watching, and I'll catch you later. Also, there will be a link in the description down below with the GitHub link to all this code.